Okay, so the question of this problem is, what is the force required, P? So P, it's unknown. What is the force required, P, to roll over this little step of 50 millimeter if the mass of the cylinder is 50 kilograms? And what is the direction of theta? Okay, so let's look at this drawing a little bit closer, because that's, I think, the key. I know that's huge. Okay. We have the 300 millimeter. What's applied on the cylinder? We have the weight. So let's find the weight. 50 times 9.81. So we have it. It's 49.81, something like that. 50 times 9.81. 490.5. 49. It's 49 times 10. So 490.5 Newton. Okay. And we have a normal force so there that will be perpendicular to this surface, so that will go through the point A, like this. Okay, and we have this angle. So this angle theta there that we try to find too, that is the same than this one. Look, theta, 90 degrees, so theta. Okay, what can we do? And we have P, so this force P, we can slide it there, right? And theta, and this one is 90 minus theta for W. So if we do the moment about B, let's try this. If we do the moment about B, so sum of the moment about B equals 0. We have the force P that tend to rotate in the positive direction. So we have P times the distance, that's the radius. So that's perpendicular, so times 0.3 meter, right? And we have W. So W has two components, this one, and this complement tend to rotate in the negative directions. So we have minus W, that's the cosine of 90 minus theta. That is also equal to the sine, and times 0.32 equals 0. Okay, and if you do your little, so cosine, that's theta, that's cosine 90 minus theta, this one, that's equal to sine theta. So we have P 0303 minus W sine theta, that is equal to 0. Okay, so we have this first relation that we found. We need another equations because we don't know, so what we don't know is we don't know theta and we don't know P, right? We need to use something with, we didn't use yet the steps, these 5 millimeter steps. So how we can use that? We can find theta with that because we have this triangle there, right? So we have this triangle. Let's make it bigger. We have this triangle. We know that this one is 300, and we know that the total, this one is 50. So we have 250 left there. So this angle theta that we are looking for is, we have cosine theta that is equal to the 250, the adjacent side, divided by 300, right? So we have theta that is equal to, let's find this theta, the inverse cosine of 250 divided by 300. That's 33.6 degrees. So now we can use this theta in the first equation. So we have P that is equal to W, that is 490.5 sine of theta, that is 33.6 degrees. So we get P That is 450, 490, and sine of this angle. That gives us 271 Newton. And that's it, we are done. That was fast, right? So, and don't forget to use everything that's given. So the 50 millimeters has an impact because the higher the steps, the harder it will be to roll over this step. So that's one of the key information there. And after that, just try to use the equation of equilibrium, so force on x, y, a moment. That is the easiest to solve. We don't need to solve what we don't need. Like we don't need to solve for the normal force at B, so don't solve for that. And that's it for this little small problems. See you. Bye-bye.